Hi, I love following Susanna. She's a member of our editorial board and has been absolutely essential, especially since we have been using the ISO tabs. I'm not going to go into the details of exactly what GigaScience does. What I want to talk about are some pointers of things we have done and to talk about ways you might be able to apply this to what you're doing. Our main goal at GigaScience is that we are trying to create a universe entity within itself that publishes articles, publishes the data, and publishes the tools. And this is all aimed at reproducibility, reuse, and rapid release of the data. Okay, so this is my, mean slide. Currently, in scientific communication, in publication, effectively, scholarly articles really serve, in a lot of cases, just as an advertisement. The data often isn't available. The computational methods aren't available. Methods, in general, are very scant. And so the scholarship of the actual article is often inaccessible. So core scientific statements or assertions that are intertwined are hidden in the conventional scholarly narratives. So this lack of transparency and lack of credit for anything other than these dead tree publishing is a huge issue. And so we want to move beyond that. So this is how GigaScience is looking at publishing. We look at that there are different pieces of a paper that all form one whole. And there's data and software. This has to be available. If you're having data, you also have to have metadata and curation, because data, just throwing it out there, is not useful. It has to be properly marked, explained, so that people know how to use it. It has to be interoperable. If you have article narratives, you also have to be able to interact as much as possible with the analyses, with the data and the tools. And you need to have, especially with computational tools, workflows, so that it's very easy and straightforward for people to follow along with what has been done. And all of the analyses have to be transparent. So what we are doing with our journal is we have created a standard publishing platform that is linked to GigaDB, which is a database that hosts all the data sets that are associated with that article. So a main goal is, if we publish an article, any of the data that was used in that, we host it in our database. And those data sets are given a separate DOI, so the data itself can be cited. Oftentimes, people don't use the article. They actually are just using the data. And people cite the article, and when someone just wants to use the data, they have to track through that article to find just the data that somebody used. The other thing we're doing is we've created a platform in Galaxy which allows you to use computational tools. So we have interlinked all of this process together. So a lot of the data release policies right now are very complicated, that publishers are saying we can't put them out. There's a lot of data that's really hard to post. So I just want to say that it's not just for omics anymore. There are a lot of ways to publish data or to release data that isn't just these omics type things where there are these huge community repositories. So for us, we can do this because we have an affiliated database. The neuroscience community, this is a recent paper that we published, the neuroscience community typically does not share its data. This is a very difficult area to get people to share its data. Part of it is cultural, but these data are very complex. Another thing about papers in general is tools and data are not made available to the reviewers. So people always talk about, well, if you're posting the data and you're making it citable, how have you have to review the data. Now, we do, but I do want to point out that right now, nobody reviews that data. So even if we didn't, at least it's accessible. And then finally, a lot of journal editors think that reviewers don't want to review data. So here's our situation. We did this paper in neuroscience. It had these, all these electrograms of neural processes. So they weren't shared, but the author felt that in this one they were going to share it because they were able to have their data cited. So they felt that this form of academic credit really promoted that. So we hosted 366 recordings from 12 electrophysiology data sets, so which was pretty big. It's not huge, but that was with the DOI, so that could be cited. And Thomson Reuters now does data citation tracking, so this allows authors to really be more interested in this because they can have this added to their agenda of reasons I should be funded. So in addition to having the manuscript, we made the data and tools available to all the reviewers using our database, and we allowed the reviewers to be able to rerun the tools. And I want to point out that we don't always make one reviewer review everything. Oftentimes we use a separate data reviewer who does not look at the biology. Their goal is to look only at the data. So you don't have to overburden a reviewer and say, look at all of this. You can say, look, there are postdocs out here who know exactly how to do this. Did these people do this correctly? Now, this is what our reviewers, they did review the whole paper. They said that they thought it was a shining example of publication. Our reviews are all named and open. I'm not breaking any confidentiality. And they felt that it was almost as easy as pressing a button to review it. Christoph said that he thought that the reviewer's job was more fun. So I just want to highlight that reviewers aren't necessarily, oh, I don't want to look at the data. It's doable. So the next thing I want to highlight is how major data citation really is as an incentive. This week, we released the genome sequence of 3,000 rice strains. That's 13.4 terabytes of data. Now, these data were also deposited in the NIH SRA repository. We encourage putting the data anywhere the authors want to do it, but we mandate that it has to go in community repositories that the community has accepted. So if it's already there, why do we do it? Well, there's a couple of reasons. First of all, we've directly linked it to a data paper. As with scientific data, we publish data papers that describe the data production, but we also publish full articles that go through analyses but still have the data linked to them. So, but one of the projects we do is data papers. And so this allows, if someone reads that paper, to go directly to that. They can find it in the citations. They don't have to pan through and find the data accessibility and all of that. But also, this was a 3-institution collaboration, and there have been 2 years of arguing about releasing the data, a huge community resource. Prior to the analysis paper, this is a big fear of researchers, that if they release it, they're not going to get any credit. But this was finally broken when the authors found that they could release the data with us in a citable format. So this can be a huge incentive to get things out to the community very rapidly. Okay. Next thing I want to talk about is considering cross-journal support. And this is why, we have a database, we have, this platform and all of that. Maybe you all can't do all that, but, competition among journals is good, but sometimes we should collaborate for the good of the community. So, as an example, PLOS had this recent data deposition policy that led to a lot of discussion in the community and concerns about the feasibility of doing this, the funding of doing this, et cetera. Now, we support and applaud their policy. Ours is even stricter. We can be stricter because we have a curator. We help the people put it in our database, and so it's there. But PLOS One, then, they have this huge policy. Then they received this submission that was this comparative study of earthworm morphology and anatomy, and it had used microcomputed tomography to look at the soft tissues. These data are incredibly complex. They have videos, they have multiple files, and some of the folders are 10 gigabytes. Still small, I think. So GigaScience and PLOS actually collaborated. We felt that their policy was really important, so we said, we'll help out on this one. And we can look toward, future ideas of ways that for the whole community to do this. So they published the main article that had been submitted to them. We published a data note, and we hosted all the data in GigaDB under a separate citation. And we have an Aspera connection. The reviewers could download even these 10 terabyte folders within a half an hour. So the reviewers were able to look at the data that was published in PLOS. One of our reviewers said that basically the sharing of this data meant that instead of having to go through this lengthy process of getting samples from museums to study these samples, she could just download this information, so the data that someone had already made could now be used without someone else having to go through the expense. So these are just some things that I think you need to think about. I think you should be promoting rather than inhibiting pre-publication data sharing. Authors are already nervous about sharing their data. They don't need editors saying, you know, someone might scoop you. They already know. You should promote data citation in reference sections. It incentivizes data release, and it makes it easier for the reader to find. You should promote data sharing upon publication. Consider your data release policies. Should you push for stricter data release policies? Yes. Form collaborations with repositories like Dryad and things like that. Identify the community organizations and their metadata standards, and make the data available for your reviewers. At the author's website, the community repositories, Dryad, similar, your publishers should think about creating just a site to upload and download data. At least do a sanity check. It's not easy. I'm not saying do it all now, but think about what you can do now and move toward the rest. So it's time to move past this. Thanks. This is my team, and they did all the hard work. Thank you very much.